as far as I know, most of this stuff has never been tried. So we're like poking the limits here. Every time you talk with people, like you install this, then you configure this, then you install that. Users are like, I'm not going to do this. With Floresta, you can have an extremely lightweight node that still gives you like excellent privacy and security. The goal with Floresta is to get something like in the middle that can give people better trade-offs, but still being lightweight and something that the average user can run on like average hardware.
Hi everyone, and welcome back to Stephan Livera podcast. Today, my guest is Davidson. Davidson is a Bitcoin developer and working on known for the Floresta project, which is an interesting one. I think it can have some interesting implications for you, whether you're a Bitcoin developer or builder, or if you're just an end user. So we're going to explore some of this, as well as how it relates with Utreexo, which, listeners, you might have seen that from my earlier episodes with Calvin Kim. But Davidson, welcome to the show.
Yeah, thanks for having me.
So Davidson, just give us like a very quick background on yourself. I know you're coming from Brazil and you've been doing some interesting stuff on Bitcoin development.
Yeah, I've been working with Bitcoin open source for 3 years now with a grant by Vintium. I have a degree in computer science, and I've been doing Bitcoin stuff in the background for, 8 years. And my main project now is Floresta. It's a project that I started as a side hustle, but became a actual thing. So I've been working on this full time, basically like 2 years now.
Okay, so let's start with that. So what is Floresta and what's the goal here?
Yeah, so the main goal here is to explore different trade-off sets for Bitcoin clients and to provide alternatives. So with Floresta, you can have an extremely lightweight node that still gives you like excellent privacy and security. And it's something that I feel like we don't have this in Bitcoin right now. You either have to expand all the resources in like actual full node with all the hardware requirements that you have, or you completely trust someone. The goal of Floresta is to get something like in the middle that can give people better trade-offs, but still being lightweight and something that the average user can run on like average hardware.
Okay, yeah. So I guess let me just try to contextualize this for listeners who aren't as technical or aren't as into the weeds here. So when we use Bitcoin, you have to connect your wallet to something so that you can understand what is the state of the chain, what are my transactions, what is my balance. And typically the way people are doing this, like what most people are probably doing, is just trusting a server with telling them what are their balances, what are the transactions. Now, there may be some SPV elements built into that, but generally speaking, there's a lot of quote unquote trust me bro involved. And then on the other end, people might be running, let's say you might be running an Umbrel or something similar, or a Nodebox. And in practice, what people might be doing is they might be running Bitcoin Core and an Electrum server, and then having a wallet software, maybe it's Sparrow, maybe it's Nunchuck or something like that, and pointing to that Electrum server. But the challenge then is it requires someone to run, a much more involved setup. It requires, cost, time, expertise even. So that's kind of my broad high-level understanding. Can you give us an idea, what could it look like in a Floresta world? What would that trade-off look like for the end user?
It's extremely lightweight. So just to give you a context, I run it on mainnet right now. It uses 300 megabytes of disk and like 200-ish megabytes of RAM. So it can run on any device basically. And regarding like the actual security model, you can actually choose. I don't think the final user will choose this. We can talk about this later. But you can actually choose which security model is fine for you. There is the proof of work fraud proof, which we'll also talk about in a little bit. There is the assume Utreexo that you can use, and you can do IBD regularly. So you can actually tune it to like, I'm fine trusting the binary with assume Utreexo. It's the Utreexo version of assume Utreexo. So there are different trade-offs you can make, but they are all like a big improvement over what we have nowadays. But you can run, if you want, you can run it just with the same trade-off sets as running a Bitcoin Core. Like you validate everything from Genesis to tip. It takes a little while, obviously, but you can do that with minimal hardware. You don't need to have like a good SSD and all the stuff we need to have to run like a regular node because you're not going to be using that. So you can basically do that in like more uh, more attainable hardware.
Yeah, I see. And just to, again, to contextualize for listeners who aren't as familiar, if you run your own full Bitcoin node and you like are running, what's called an archival node, the chain today is something in the range of 800 gigabytes. And obviously it takes some time to actually run what's called IBD, initial block download. And so, as you mentioned, this would dramatically lower that requirement. And so then, hypothetically, the proverbial grandma per se, or just someone with a phone can have a client that is validating in a much better way than I guess what a lot of those people are doing today, which is just basically quote unquote trust me, bro, or at least it's closer to the trusting the server, basically.
Yeah, and another improvement is that when you are using like Electrum, which is the protocol we use to talk with those servers, you're giving your wallet's scripts, like your addresses, to those servers.
Right. It's like a full privacy doxing.
Yes.
And just to be clear, now, to be fair to the Electrum guys, the reason it's an OG wallet before my time, but they were from like 2011 or 2012. And Thomas has explained, like at that time, his concern was a lot of people are just going to trust exchanges. And so what is the way to have people be able to at least hold their own keys, but, trust Electrum servers to an extent? And of course, as you mentioned, with privacy. So it was a step forward at the time. But now there's a lot of people who are using that, and without knowing, unknowingly, many times they are just using it, and it's calling out, and basically they might be connecting to random Electrum servers, unless they're connecting specifically to their own Electrum server. Like if you run the Umbrel or Ministry of Nodes node box or something like this, then you are effectively just kind of doxing out your coins to unknown servers, right? And it's been known in the past that Chain Surveillance and other people will run those Electrum servers for free. Because that's part of their business model to help sort of.
That's like an obvious honeypot, right? It's like the most obvious honeypot you can have is run an Electrum infrastructure, because people are really giving you their addresses. So
yeah, and so basically this is another reason where people have, in the Bitcoin, let's say, world, people talk about running your own node because it helps you from a privacy perspective, as well as just kind of operationally, you need to do it if you want to be able to be sovereign.
Yeah, so with Floresta, you keep track of your balance locally. And we have something called Watch Your Own Wallet that keeps track of your transactions. You give it a Xpub or a descriptor. It will keep track of your transactions. And when you connect your wallet to it, your wallet can request those transactions and fetch the balance from your own running Floresta. So you don't need to dox yourself to anyone else.
And so can you just spell out a little bit about what it is? So as you've mentioned, it's a Utreexo-powered Electrum server. And so can you just talk us through what that means? Like, what does that mean for the end user? Like, you run this and you can just point your Electrum wallet or some other Electrum, like a wallet that speaks the Electrum protocol per se, to your Floresta, and that way it's like you're running your own Electrum server, right?
Yeah. That descriptor actually needs to be improved a little, because that's the same descriptor I had since I started the project. But yeah, that's the idea. The idea is to have something that has the least amount of friction as possible. Having to install multiple binaries and configure everything. Every time I talk with people who are not technical and say like, oh, install Bitcoin Core and then like an Electrum server, they're like, can't I install like one thing and use it? So the idea is, you have everything you need in one package. There is the actual node that does like all the validation stuff, downloads things from peer-to-peer, connecting with other Bitcoin Core nodes, validates everything, keeps like track of transactions and addresses. There is the Watch Your Own Wallet, that where you give your Xpub or your descriptor, and it keeps track of your transactions. And there is an Electrum server. This is not a full indexer like ElectraS, because those you can request like any script, any address that receives transaction in the whole history of Bitcoin. I frankly think this is useless for like my mom. She's not gonna like look at every single address that ever received Bitcoin in the whole history of Bitcoin. And that index is kind of big, it's like 100 gigs, depending on the implementation. So it only keeps track of your own transactions. That's like all it can answer. And that's okay for like
And
most
just to
people.
be clear, does that mean you need to just because this might be come up as a question? Does the user need to input their, as you said, their XPub or output descriptor before starting Floresta D so that it knows to watch for these particular addresses, or can you just like put it in later and it will then have to do like a rescan?
You can put it in later. You just need to use something called compact block filters. We support this by default. It's a way for you to like do rescan. So try to find historical transactions in the chain, but without need to download the whole chain because Floresta is pruned by default, so you don't keep the old blocks. But you can use compact block filters to find all the transactions. And you can use that. You can add your addresses at any time. And there is a possibility of not even requiring that. It requires change to the wallets that use the Electrum server. I actually proposed this to the Electrum guys, and they are changing the protocol. But these things take time to go through. I think they're calling it version 1.7, if I'm not mistaken. If you replace, do you want to go to like nitty-gritties here, or just say that it's possible?
Okay, so let's just start with that. And I guess just again for people who aren't familiar, this compact block filters, I presume here you're talking about like what's known as Neutrino or bit 157, 158, yeah?
Yes, 157, 158.
Yes, gotcha. Okay, and so my understanding with that is that came up. I mean, it's been around for a little while, but basically it came up because what was there previously, this bloom filter thing was not that private, and people were like, okay, why don't we have this? And it was, as I understand, it was used in some wallets, like even in some of the early version of Breeze had this, but as I understand, it's not really that popular nowadays, at least in like mobile wallets. Can you talk a little bit about that?
Mobile is always hard. Like we can talk about mobile, but it's always hard. Like we try some experiments and it's really hard. But on computers, it's fine. I think Bitcoin Core is moving to perform the wallet rescan using filters. It just builds the filters locally, but it can use it. And I think for desktop, it's completely fine. You can run, like LMD, the implementation, you can run it with Neutrino. Neutrino is a specific implementation of compact block filters by Lightning Labs.
Right.
You can use Neutrino's SPV and compact block filters. With BDK, you can use BDK with compact block filters using something called Kyoto, which is also an SPV client that uses compact block filters to find stuff. So anyone who uses BDK can use compact block filters. So I think like the tooling is getting better, so more people are probably gonna use it. And the advantage of using with Floresta, like Floresta and compact block filters, is that you're not SPV, you are actually validating. So you are a full node with compact block filters. But with compact block filters, you can find those old transactions on chain without needing to go through all blocks.
I see, yeah. And so my understanding is it's sort of like a fancy way of filtering and understanding which blocks you, the user, are interested in, and then you fetch the entire block, so that way you're kind of doxing less about exactly which transactions you're interested in, and therefore in that way it's a little more privacy preserving.
Yes.
Is that correct?
Yes, it is built for every block, and it contains let's say the addresses that's being of Utreexos being created and for Utreexos being spent. So you in the filter you can ask it like, here's all my addresses. It's actually scripts, but let's use addresses. Here's all my addresses. Does any of those addresses appears in this block? And the filter will tell you definitely no, or maybe yes. If it says maybe yes, you download the block and you look for whatever you like your address, whether it's in there or not. It also has a false positive rate. It's like a probability data structure. So it says sometimes that it is, but there isn't. And this is actually good.
Right, it's kind of like bluffing that I need that block, even though I don't really need it,
Yes.
just for the privacy preserving part. Okay.
Yeah. It's not like the reason why the filter does that's not for privacy. It's how it works, but it's good for privacy because you can then download some blocks that are like decoy blocks. You don't need them, so people can correlate, like look at the blocks you download, and
Right.
these are the blocks you are interested. Like maybe I'm not interested in the
I
block
see.
at all.
Yeah. And one other question, actually, just because you mentioned scripts rather than addresses, does that mean it only works in certain like script types, like, or does it handle everything like P2SH and P2WSH as well as pay to taproot, or is it only like one specific thing that it supports, or only the newer stuff?
No, it supports any spendable script, I believe. I think it doesn't index upper return and things like that, but anything that is spendable, it can. And like if you were addresses, then you couldn't, right? Because there are some scripts that don't have addresses associated with them, like non-standard scripts.
Okay.
So if you were scripts, you couldn't do some weird types of outputs. But I
Okay.
believe every single script, whether or not it's standard, I think it goes into the filter.
Okay, gotcha. Okay, so let's talk a little bit then. So yeah, we're sort of talking a little bit high level, but can you just give us an idea of who do you see as the users of this? And then we'll get into like what should developers know. So let's just start with the users part. Who do you see as typical users of this, of Floresta?
Yeah, I usually think about like the non-technical people that are not gonna like run weird infrastructure on top of it, that are just, I need something to connect my wallet with and do my Bitcoin stuff. So less technical people who don't work with Bitcoin at all, like just have some stash of Bitcoin. So basically general public, like people who want to have better security and privacy, but doesn't want to like have Bitcoin Core or whatever.
I see.
It's like more resource footprint. That's usually the type of public that I'm targeting. This is why I can make trade-offs like this is proven by default, because I don't see people who, like normal people, going through like old blocks, like processing old blocks and working for them.
And for now, this is a desktop application only, but the idea is it could be used in some kind of mobile app.
Yeah, it's a demo. It works the same way as Bitcoin D. You run on your terminal. We have plans to make a actual app for it, like with some UI and things like that. There is work because Floresta is also a library. So this is another thing I put a lot of emphasis in, because I don't really think the end user is going to use Floresta directly. I think this is not the way to go. Maybe exactly because of the strict thing, like too many things to run. So Floresta is a library. You can embed it on anything. It's like written in Rust, so you can call it from any other language, and you can use it very easily. The same way like BDK, I have applications that use BDK that are written in Python or that are written in like Java or other languages. You can do the same with Floresta. It runs under the same application. So let's say you open a wallet on the background, that wallet starts Floresta and it's running there. The wallet's like asking Floresta for stuff, and you don't need to like open up a bunch of different applications and leave things running that you don't even know what it is. So there is this library component that can be reused. We even have someone working on integrating it with BDK. So users of BDK can use Floresta as they call it the chain source, which is how you communicate with the blockchain. You can use Floresta. And the mobile things is more like experimentation. Last year, me and a group of friends, we won a hackathon here in Brazil with a wallet. It was a BDK-based wallet that also ran Floresta in the background. So everything was running on the same app, and you could like fetch your addresses and everything locally. So the only communication you did was normal peer-to-peer communications. It wouldn't be doxing you, and was validating everything locally.
Fascinating. Okay, so the way I'm understanding it then is you envision end users not really using Floresta D. Like if you're talking about proverbial grandma or mother, it's more like developers might package this into an app and it will use either the library in the background to make it accessible to have better security in Bitcoin and maybe better privacy compared to just doxing your addresses to the Electrum server.
I feel like this is like this project is very experimental. We have to tell the listeners to take everything here with a grain of salt, because as far as I know, most of this stuff has never been tried. So we're like poking the limits here.
Yeah.
But
right. But I guess what we're saying is this is the goal. The goal is that
I feel like
developers could build this.
This is the best UX, right? Every time you talk with people, like you install this, then you configure this, then you install that, and then users are like, I'm not going to do this. But if you say just install this, and everything will be running. They are like, okay, it's just one thing. It's like, it's unfortunate, but that's usually how most people's brains work. So I feel like this is the best UX you can deliver.
Interesting. And look, if it does get proven out, then maybe Floresta gets built into existing, Bitcoin apps. So I guess let's explore that for a second. Like, could hypothetically, like, let's say this all works out, could it be built into existing Bitcoin phone apps that people already know and use? Like, I don't know, like a nunchuck or a blue wallet or these kinds of typical on-chain wallets that people already do today.
Yes, like 100%. And the way I'm working with it is making it easy to do that transition. So it's like, I don't know, 5-6 lines of code that you need to change because it's Electrum. So you already have the Electrum infrastructure, like we have the Electrum server. You just need to install Floresta. Like you configure Floresta, you start it, and that's it. Everything else I'm doing for you on the background. You just need to connect with your local Electrum server, and everything else is transparent. So the idea is, if this works out, everything we are trying to do, we can actually pull it off, having existing applications just replacing their Electrum infrastructure with this, and it's very easy for them. Like if it was too difficult, I wouldn't reasonably expect them to do that, but it's so easy to do that. I don't see why not.
I see. And so just to give people an idea then, it means if people were to go down this pathway of using quote unquote assume Utreexo, it means like a user could just install one of these on-chain wallets, like we said, a blue wallet or a nunchuck or maybe the Blockstream app, basically any on-chain wallet today that can call out to an Electrum server, which is many of them, basically all the good ones. They could just like install this app and basically just like straight away be ready to transact.
Yeah, and be validating everything from the Assume Utreexo onwards. So like your transactions, you're actually validating those blocks.
Interesting. Yeah. So let's explore a little bit, maybe one step deeper. How does this actually work? Because as I understand, it's like you're combining a few different ideas here. Like you've got this Utreexo concept that you're leveraging. You're leveraging this proof of work fraud proof method and like Electrum servers and kind of rolling it all together. That's how I'm understanding it anyway. Can you just maybe sort of take it one step deeper? What's going on in the background here?
We have a bunch of different things playing together. Floresta will have like different modules that implement everything, so you can like poke around and only use some parts, like the BDK thing. You want to use Electrum and want to use the Watron wallet because BDK is a wallet, so they're only going to use the node functionality. So everything is separate, and we have a Bitcoin Core compatible JSON RPC. We don't have all the RPCs yet, but we're trying to make them. So it's going to be easier for example, let's say loading a box once you have a lightweight version. So like Umbra, for example, they can have this and they don't need the applications changing their RPC to support Floresta because Floresta is compatible with Core. So it's like a drop-in replacement. We have the Electrum server, we have compact block filters, and a few other stuff. So it's everything that this is like the interfaces you can communicate with Floresta. We're not trying to do anything new because we know new standards are just like more noise. We're not going to make the whole industry change for a new standard, even if the old standards are not that good. So we're just like, okay, you already have this, let's implement this, and you can communicate with us more easily. And in terms of technologies for the node, we have like for IBD, which is the hardest path every time. Like every time you're talking about nodes, the IBD is always the most complicated part. There's 3 ways you can do this on Floresta, and we have different ideas on where each of them goes better. You can do IBD regularly, like any other node would, just start from Genesis and download blocks and validate everything until you reach chip. There is Assume Utreexo, which is the Utreexo version of Assume Utreexo, where you assume that a given block is valid. So let's say block 900,000 something is valid, like everything before it is valid. And in the binary, there is the root, like the accumulator state for that block. So you don't need to go back. Those other blocks should know what's the current state of the network. So you can start from that point and download and validate everything that comes after. So you start at the block and you validate everything after. And then in Floresta, you implement the same way that Bitcoin Core does, that you can go, like you can split your validation in two parts, and then you have one part that starts on that block where you assume. So let's say we assume block 900,000. We start at block 900,000 to tip, like I think it's 910 something like blocks now. And another thread starts as Genesis and go all the way up to block 900,000. So you're still validating, but your nodes is ready to use faster.
Right. So it's like a back syncing, or how does it, like, well, what's the right word? Is it like a
I think
parallel?
they call backfill.
Backfill. Yeah, that makes a lot of sense. So it's like the idea is you could quickly start, but actually in the background, it's also doing this backfill to make sure you are on the correct chain and validating that.
Yes, and then when you arrive at block 900,000, you compare with what you had in the binary with what you obtain, and if they are not right, something's clearly wrong. Like if they are not equal, something's clearly wrong. In Floresta, you can disable this backfilling. There is an option for disabling it. I think in Bitcoin Core you can't. You always have to backfill. But we have this assumed Utreexo, and then you can optionally do backfill or not. If you choose not to do backfill, it's just gonna catch up with the blockchain and you know this set. And there is this more like unexplored part with its proof of work fraud proof. This is an old idea, I think 2017 by Ruben Samson, but as far as I know, no one actually implemented it in like a actual software, production ready software. It allows you to skip IBD completely to a fairly recent block, and you are safe, like you are following the correct chain, as long as you're not Sibo, like you're not being eclipsed attacked, which is sort of the same assumption for every node. Like if you're eclipsed, they can make you accept
Gotcha.
least work
Yeah,
chain.
sorry, just before we go into this, let's just summarize a few points there. So you said that you can do like standard IBD, just download the chain, but that's like one way. Another way is assume Utreexo with backfilling or not. And so I just presume then if you are on a phone, you're probably not going to backfill, but if you are on a desktop, maybe you would. That's like loosely how it might work. And then maybe that's how developers of apps for the desktop or for the phone, that's probably how they would do this. And then
that's my thought.
Right. And so now let's get to this proof of work fraud proof thing. So can you just maybe let's just start with, what's the goal of that and what is that?
It's a way to IBD super fast because you don't have to validate blocks. You basically skip validation, but in a way that improves simple SPV. So simple SPV, you have this assumption that 51% of the miners, of the hash rate, has to be honest, 50% plus one. But if they are not honest, they can attack you. They can make you accept invalid transaction, and there is no way for you to know they are doing something wrong. Satoshi introduced this term. He mentioned something called fraud proofs, which is nodes can tell you hey, this chain is actually invalid because of this, but it's very hard to make fraud proofs because they are very dosable. So it never worked out the way Satoshi mentioned in the white paper. Proof of work fraud proof it's not really a fraud proof, it's kind of sort of, but it's going the same direction. And the idea is this, can I skip IBD in a way that I have better security than SPV, and that I can actually find invalid blocks. I can actually determine that this block is invalid for some reason. So this main chain block is invalid for some reason, then I can switch to the least work chain, but that's the correct one. And then I can follow the same network that a full node would, if that makes sense.
This episode is brought to you by CoinKite, the makers of my favorite Bitcoin hardware wallet, the Cold Card Q.
Now, some people think self-custody is too hard, but it's really about taking responsibility for your Bitcoin wealth and understanding that self-custody gives you a true feeling of liberty. The Cold Card Q has a full keyboard and big screen. It's got 2 secure elements and a true air gap, allowing you to go fully air-gapped using QR codes from seed generation to transaction signing. You can power the device using 3 AAA batteries, so you don't even have to plug it into the wall for power. You can easily use it with Sparrow Wallet for PC or Nunchuck on mobile, and you can dial it into the right level of security and complexity that you choose. If you want a simple setup, just use 12 words and single signature. If you want passphrases, easy. If you want to add multi-sig or co-signing features, you've got those too. So go to coinkite.com, use code Livera to get 10% off on your cold card or other devices and level up your self-custody today. And so the idea is you can quickly get up and running. And as I, just from trying to read it a little bit about it, as I understand, it's like you're trying to look back at some of the recent blocks to understand, was there a fork or at least a fork attempt in those last few blocks, might be like 100 blocks or whatever it is. And as I understand, that's tunable. And then the idea is you're looking at that to understand, kind of in a loose sense, how confident am I that I'm on the correct chain?
Yes, you basically assume that some percent of the hash rate is honest. It can be as small like 10%. So you would need more than 90% of the network hash rate to attack this. But as long as some hash rate is honest, like some miners are honest, they're going to create a fork because there is an invalid block. They invalidate this block and then they start working on an alternative block. So they create a fork, and then there's 2 blocks in the same height. So what you do is you look for those, and then you try to tune this to not get any block you can find, because otherwise you could be DOSed as well. But like with a reasonable amount of work, you look at it and you download the main chain block and rewind your state, like basically validate that block as any other node would, and you figure that that block is invalid. So you now know that block is invalid, you just invalidate that whole chain and goes to the other chain. So because those miners are very fairly guaranteed to find a block in the last, like say 200 blocks, there should be at least one block for this minority. You can be very sure that if there is none, there is no fork, then either there is 100% collusion for the hash rate or that those blocks are valid.
Does the headers chain play into this at all? Like you would see what is the network telling me the latest like headers chain is, and then you're looking back at the last, 100 blocks, doing this.
Yes, everything.
Right?
Everything is done with the header chain, yeah. You look at the headers, you sum up the work using the headers, and you see the different chains. You always start assuming that the main chain is the valid one, and then you look for forks from the main chain blocks. And if you find a fork from the main chain block, you download the main chain version. Like the main chain is the most worked chain you could find. You take the version for the main chain, validate it, and if it's invalid, you invalidate that chain and goes to the other chain. And you continue doing this iteratively until you only have one chain.
Yeah, interesting. And so then the idea that Ruben is putting out here, or that he put out, is this idea that you can raise the threshold for somebody to attack you from being 50% plus 1 to maybe it needs to be like 90% of the miners are trying to trick you, which, I mean, even that is already a pretty like crazy sort of, imagine if 90% of the network was already malicious, then it's kind of already like you've got other bigger problems at that point, right?
Yeah, it's kind of bad if 90% of the hash rate is. We can make it like close to 100, but we can't. The problem is the bigger we make it and the smaller we make the lookup, the harder it gets to actually analyze because of variance. Because blocks are not found exactly like if you have 51% of the hash rate, you're going to find 51% of the blocks. That like averages out over time. But if you start checking smaller percentages or smaller intervals, then the statistics don't play out here because you have to average out over like bigger intervals. But you can make it over 90%. Like you can just make a ridiculous number. Like at some point, just solo miners will be able to find a fork and basically get the majority share.
And just to be clear here, what are we defining here as honest miners? Can you just explain that for listeners?
It's the same definition as the white papers, which is a node that's following the chain that's valid by consensus rules. It doesn't mean that the person is a good person,
Yeah,
like
not a
a
morality
charitable
test, let's
person.
say.
Yeah,
Yeah.
no morality. First, in the context of Bitcoin full nodes means someone that's following the consensus rules.
Yeah, and that's, I guess, kind of broadly speaking, yes, following consensus rules, and I guess people say this term heaviest chain, right? Like most accumulated proof of work chain is the one that people are following. Although I guess there was a slight, I guess, wording shift from the white paper to what's actually in practice there. But I guess that's, as I understand, when I talk to developers, that's kind of heaviest chain rule is what they
And
say.
the white papers say longest, but longest is
Yeah, because longest
insecure.
could actually be not the heaviest chain. And that's where this kind of
Yes.
heaviest chain concept came, as I
Because you,
understand
you, you
anyway.
can make you can make lower difficulty chains, and this will be longer because
Right.
it requires less work per block. So with the same amount of work, you can make a longer chain, but that's less work.
Gotcha. Anyway,
So
let's just say that's kind of a technical point that, basically all the Bitcoin developer, like hardcore Bitcoin developers already know that part. So, we'll leave that. So just coming back to comparing the models. All right. So as you've explained, what we're talking about here is in the proof of work fraud proof method. Let's compare that, right? So now excluding the full node download the full chain for yourself and validate everything. Obviously that's the least trusting or the most trust minimized model. If we compare proof of work fraud proof method versus SPV versus fully, just trust the server. Can you just explain a little bit on the differences there? I know we were touching on this, but if you could just kind of elaborate a little on the difference between those three.
it's all about like being more sovereign about what you're doing, because with proof of work fraud proof, you can also know what's the state of the network for the block that you did this whole process. So you can actually start validating after that. So blocks that come after that, you can validate them. You just don't validate the blocks in the past. And there is an argument to be made like blocks in the future, like blocks that are new or blocks that are coming, are more important to validate than older blocks, because if like a block 6 years ago was invalid, like what are you gonna do about that? You're not gonna like, I don't know, invalidate that block and undo 6 years of work. But a block that's coming out like the next block, it's very important for everyone to look at it because it may be invalid. And we have time to do something if it's invalid. The security, like you always, when you talk about security, you're always talking about how hard it is for someone to attack you. You can't be 100% safe. Even your full node on blocks isn't 100% safe. You can be eclipsed, for instance. But it's always about how hard it is for someone to attack you. The worst method in this case for like how hard it is for someone to attack you would be the trust the server, because, well, it's just a server. The server lies to you,
and you're done, right? Like, because they can tell
you're done.
they can tell you received coins, but actually you didn't, and your client app at that point has no way to tell the truth or not, right?
Yeah, and sometimes people don't realize that they can just lie by omission. For example, they can just not tell you about a spending transaction from your Lightning channel that spends the channel in your old state. So by just saying like, I don't know any transaction related to this Utreexo, they are messing up with you, like, because you have to know that the channel point was spent.
Right. It's especially important in the L2 context. Yeah.
Yeah. So just by like not giving you information, it's not that they craft information. It's just by not giving you information. It's we call it lying by omission.
Lying by omission. Yeah.
Yeah. Just by not telling you something, they can mess up with you.
Yeah.
So it's
gotcha. And so like that's the trust. That's like the full trust the server model. Now, for an SPV context, that one is coming back to like what are the ways you can be lied to or tricked? We're coming back to again the 51% mining part of it, and you're not checking every rule.
Yeah, and with SPV, which is just assume that the chain with more work is the valid chain. It's valid. It follows the consensus rules because there's this idea that we assume that the most proof of work, like the most amount of workers, they are honest, following the honest definition from before. So if the most amount of work is in this chain, this chain must be valid because they are all following the consensus rules. And the way to attack you, to fool you into accepting an invalid transaction, for example, would be to have 51% of the hash rate and doing like getting some consensus rule messed up, like not checking some consensus rule, and then no one's gonna check, like you're not gonna check it, so they can pass with that lock, and you're not gonna respond to it. And one person using it nowadays is very hard to get 51% of Bitcoin. It's so big now that it's hard for just one, like the amount of hardware and electricity you need to get 51% seems out of reach for one person, one entity. Only if Poles do some weird coalition that they maybe can get this big. Nowadays, I think it's not really that. I don't know. I'm not looking at a lot of it, but it looks like it's hard nowadays to get 51%. But the problem is if everyone is using SPV, then you get a problem because then they are very incentivized to do something nasty because no one's checking. Like if no one's checking, like what they don't have anything to lose. Like no one's checking anyway, so they just join together, like create Utreexo with 21 million Bitcoins for them, and no one's checking, so no one's gonna do anything about it. So the main problem here is one of like a philosophical problem. This is something that was debated in exhaustion during the block size wars, because if everyone or like the majority of the network of the economic like the economic majority is using SPV, then miners are even incentivized to do this because no one is gonna oppose them. Right now, we assume that because people are checking, like the majority of the economic power is checking, if they do something wrong, they're gonna lose their money. So they're incentivized to not even try because they're just gonna lose their money. Like everyone is gonna reject the block. But if no one is validating, then that means they don't get punished and they can pass with changing
Gotcha.
invalid,
Okay. Yeah.
getting invalid block.
Okay. Yeah, cool. So, yeah, I guess we'll summarize that aspect of it by just mentioning, as you said, the proof of work fraud proof method just provides some, some better, let's say, better trade-offs for a user who is not going to do the full like IBD and download everything. And it can, I guess, the idea can maybe be to help people get started quickly and ideally still backfill so that they are then, fully
it's
validated.
important to remember that this is you should not compare this to an actual node. You should compare this to like SPV or the client, because sometimes people say, oh, this is worse than running a node. Yeah, like running a node is the best thing you can do. Like it's the gold standard for doing Bitcoin stuff is running a node. But right nowadays, most people are doing the SPV or trust the server setup. So we're improving that. So this is usually what we need to compare with when I'm talking about proof of work fraud proofs.
Yeah, gotcha. Okay, so let's talk a little bit about the relationship between Floresta and Utreexo. So as I understand, you have lib Floresta D, right? It's a library, Floresta. And then Calvin and the Utreexo guys have Utreexo D. So as I understand, can you just explain a bit about that relationship there?
Yeah, these are like Utreexo is like a spec. It's more of an idea with the bips and also then you need the implementations, and the actual Utreexo stuff, like the accumulator stuff, is implemented right now, as far as I know, in two libs. One that Calvin working with, it's called Utreexo. It's written in Go, and I wrote the one in Rust. It's called Utreexo. As far as I know, there is a partial implementation for Slackware, but full functionality. These are the only two implementations of Utreexo I know of. So this is the actual Utreexo stuff. And then there is the implementation of Bitcoin nodes that use Utreexo to make the node functionality. So you have Utreexo plus like peer-to-peer, block storage and all that. And the way we usually discuss this is Utreexo D is more like if you want to do something more like a replacement, lightweight replacement to BTCD or Bitcoin Core. It keeps more stuff. It has more functionalities because it's like a fork of BTCD. So you can do basically anything that BTCD can. So you may not prune, you can keep old blocks if you want. So it has more features. It behaves more like Bitcoin Core. It has more stuff that you can do. And Floresta is made to be embeddable. So for example, one thing we need to do that I don't think Utreexo-D needs to work as hard as we do is binary size, because usually when you're talking about something that is like a library, the size of the actual artifact is very important, especially if it's like mobile. If you have a library that's too big, people are going to complain about this. And also it's like, we don't keep most of the information that Bitcoin Core does. We don't keep like revision data. We don't keep blocks. We don't keep a ton of stuff. We just remove a lot of functionality because we just want to be like a super lightweight client. Our goal is to make something very lightweight and embeddable, like easily embeddable into other applications, so people can build those things we've talked about.
Understood. So we could say Floresta is for a more specific purpose, and it's designed to be embedded into, could be lower power devices, whereas Utreexo and Utreexo-D are sort of a broader idea that you are, like Floresta is relying on, but I guess it's a different piece of software. Is the key point to understand.
Utreexo is the idea. Utreexo-D is just an implementation, right?
Yeah.
It's a fork of BTCD. It's a Go code. It's like a code base. The relationship here will be like Bitcoin and Bitcoin Core. So one is like a protocol, like an idealized thing, and Bitcoin Core is the implementation of that. Utreexo has two implementations, which is like two clients that use Utreexo.
And the Go client.
Yeah.
Now, I guess one other point I'm curious, just if you could explain this. My understanding from Utreexo is there's a concept of bridge nodes, and they serve up these proofs. And if you are, I think the concept Calvin explained to me is a compact state node. And so that's like the mobile client who's just downloading the proofs. So is Floresta helping people be a compact state node and then downloading proofs from the Utreexo bridge nodes? Have I got it right there?
So this part is a bit annoying because there is actually two terms. Because we talk about, there is historical blocks and there is the Utreexo set. Okay. Those are two different things. Yeah. And Utreexo, we actually separate these into like two terms, and you have like different combinations. If you have the accumulator is like a big file that you need to keep to generate those proofs. So let's say you want to prove that any Utreexo is in the Utreexo set. Then you need to keep this structure, we call it a forest. You need to keep this all the way, like you need to keep this with you. You can't just throw it away. If you don't want to prove anything, then you can just keep a tiny portion of what makes this forest. We call the roots. It's less than 1 kilobyte, like super tiny. If you have the ability to generate proofs, you are a bridge. This is what it means to be a bridge. You have the forest, you have the whole thing. It's like 20 something gigs of a file. It uses a lot of I/O, so you need to have a better computer to run this, but you're a bridge. And we need bridges because wallets don't keep proofs for the transactions, so we need someone to generate these proofs on behalf of the wallets and attach to transaction blocks. If you don't keep this, you are a CSN, a compact state node. Floresta is a CSN. It can't operate as a bridge. It's one of the things like where we make a trade-off from Utreexo-D can operate as a bridge, and Floresta, we don't want this because we don't think the users of Floresta.
It's not the purpose of the project, yeah.
It's not the purpose, yeah. If you want to run a bridge, run Utreexo-D. Then there is the archival characteristic of a node. Whether or not it keeps, when we talk about Utreexo, whether or not it keeps old proofs. So you have like every block, you have proofs for the block, which proves the Utreexo is being spent, that they were in fact in the Utreexo set. So if you have all blocks and all proofs, specific all proofs, you are an archive node. So you can be like a Utreexo, like a CSN archive. You can be a pruned bridge. You can be like a pruned CSN. You can be an archive CSN. So there's four possibilities.
Okay. Yeah. So it's a bit more complicated.
Depending on whether or not.
Okay.
Yeah. So you can actually run. I think there's some that doesn't, but ideally you can run all of them. So let's say I have a beefy machine with a good SSD, but I don't have all the storage to store all the proofs. So you can be pruned bridge. I don't have a good SSD, so I don't want to generate the proofs, but I want to serve the proofs to other nodes. Then your archive CSN. So there's like variations, so it gets a bit messy.
Gotcha.
But
Okay, right. So yeah, and then the bridge concept, as I understand the idea that the person who's running that bridge node, that person is like a professional, or let's say, like a more technical person, and the idea is that the kind of the end user is just doing like Floresta with a CSN compact state node sort of thing. That's loosely how it's going to work.
we have this idea that bridge nodes are going to be rare, and most people run archives. So you cannot generate proofs, but you can serve proofs
Yeah.
for blocks.
And I guess just to be clear here, the cool thing here is that while the compact state nodes might be calling out to the bridge nodes, it's a proof, right? So they're not trusting. They're able to actually know.
They are checking everything. Yeah.
Right.
If the bridge node's lying, and technically they connect with an archive node, right? They don't know they are connecting with a bridge.
Yeah.
You just need someone that has the proofs. I don't know whether or not they can generate this proof. In theory, this is very flimsy, but in theory, you can have just one bridge for the whole network. Because once this bridge generates the proofs, it propagates through the CSN network, and the archive CSNs will keep those proofs around. So you just need to connect to those archive CSNs, and they can serve the proof.
Okay.
You just need one person to prove it.
Yeah, interesting. So yeah, that's kind of a deeper concept. Okay, well, I think we'll cut that particular thread. Let's go now to the node costs aspect, because this is a common talking point. People are saying, well, is the cost of running a node going up? People having to run SSDs. Now, as I understand, today a 1 terabyte SSD is probably okay, but in practice you would probably want like a 2 terabyte SSD for like if you're doing a full node, because you want to be able to, to be clear, I should use the term archival node, right? If you want to store all the blocks and you want to be able to have some decent runway going out. But maybe you can explain for us a little bit of your thoughts, like what are the implications of some of this stuff like Utreexo and having Floresta D? Imagine a future where these get used more. What does that mean? Like as the chain grows, does that mean, we might see more interest in this kind of technology?
Yeah, especially the Utreexo set going up. Now it's going down, but it went up a lot, and it made really hard for some people to run nodes. I know we have a big community here in Brazil of Bitcoiners, and as far as I know, the biggest Portuguese-speaking server of Bitcoin is one of that I and some friends run. And there's a lot of people who say, I tried to run a node, it took like 2 months, so I just gave up. One thing that I usually need to talk down, that I see a lot of people, especially in the US, say, it's just $300. I have to remember that not everyone lives in the United States. And $300 is I think $350 is the average household income like per person in Brazil. So every month, that's what you have to the whole budget. So hardware is very expensive in the third world, and in a lot of places, even if you can afford it, people won't. So Calvin told me that in Korea, you won't have a computer if you really need a computer, because otherwise you just have like a tablet or smartphone. So sometimes people just want. And I know a guy that he wanted to make a node, but he couldn't because he had a small apartment and like the fan of the computer was pissing off his wife. So he couldn't run the node. But I see a lot of people who say, I want to run a node, but like buy a separate computer and making sure it's running 24/7, because if it goes down, your wallet can't work, especially if you do like Lightning stuff connecting to that node. So that there's I really feel like there is space for something lightweight. People come up to me and say that they really want something lightweight, something that you can run on your computer without giving away like a lot of the I/O or the disk. And so I really think there is space for this. If you can run a node with like a full archive node, please do, because there is another problem called the data availability. Like you need people to serve this data to others, otherwise new people can join the network. But the target audience for Floresta are people who are residential network. They can't accept incoming connections anyway. So I'm gonna help with this. Yeah, to summarize, there are several challenges in people acquiring hardware and running nodes the way we say. That would be the ideal. The main evidence for it is like Bitcoin went up in price a lot. We think there is a lot more users, but last time I checked, the number of full nodes was roughly the same as 2017, 2018. So something tells me that people are not running nodes the way we wanted them to.
Yeah, my theory would be that there's a lot of people who, I mean, they've made money out of, or at least their purchasing power has gone up, but maybe it's not that much, not even that much about the hardware cost. It's more just about like ease of doing it for people.
Yeah, it's a hassle.
Yeah, because I don't even think the dollar cost of having like, okay, I understand obviously the case in Brazil is particularly one thing. Maybe if you've got like all these import duties and costs and things, but at least even if we're just talking about the Western world, most of the Western world, I would say probably most Bitcoiners in the Western world could afford to run a Bitcoin node, and they're still not, or a lot of them are not, because I think it's for other reasons than just the straight costs of doing so. But I'm curious what do you make of that? Do you think it's an ease of use thing?
Yeah, probably there is a component of use. Like a lot of people are like, too much thing to run, configure a lot of stuff. Even with node in a box, you still need to do some things. You need to install like an OS on something. So they're like, not gonna do it. So this is why I really try to make the package thing. Like, let's make everything in one app, or at least the least amount of apps possible, and require the least amount of configuration possible. So more people will do that.
Yeah, and I think for that's actually it's a really cool idea. One other area around second layer protocols, obviously like Lightning, can Floresta play nicely with those, or is it sort of like that's a separate thing and it's not really, you should use something else for that, or is it more like, yeah, you still can do Lightning with Floresta?
Most of the stuff like most of the layer tools, the only problem is when they need to request like arbitrary utexos. Like Lightning, every channel has a associated utexo, they call the channel out point. And when you try to get these arbitrary utexos that are not cached by the wallet, because they just random utexos, it gets messy. We can't right now find those utexos because we don't have the utexo set, right? Bitcoin Core can just look through the utexo set and find that utexo. We don't have that. So that part's hard. I had some talks, one in Berlin this year, bit C++. Maybe we can do this in an easier way so most Lightning mobile clients are using LSPs, right? Most of the end users wallet use some form of LSP. So if the LSPs can generate and provide this proof, it's very easy for them, like hardware-wise, because you can have just parts of the forest. So hardware-wise is fine. You don't need all the resource that you need for a normal bridge node. And if they can generate the proofs for those utexos, then it could play nicely. Like it would work very nicely. You could validate those. You wouldn't need to trust third-party servers. For everything else, like getting blocks, getting your own transactions, everything else, it works out of the box. The only challenge is finding arbitrary utexos.
I see. So I guess for now, you would not recommend somebody run a Lightning node off Floresta,
No.
But I guess even if it just helps people do their on-chain stuff, that's already a pretty big win.
There's another way to do this that would need some minor change in the Lightning clients, which is how Neutrino does that using compact block filters. It also works, but especially if you want to go the mobile route, it's kind of annoying. I've been told by some people who does that in mobile Lightning wallet that the experience can get very ugly there, especially if you are on a slow network, like a worse network. The experience gets really bad.
Gotcha.
So there is this way, it works, but it like UX-wise, it's not ideal. The other way would be more ideal UX-wise.
Okay. Coming back to just kind of how this could get used in practice, if we're talking about the hypothetical, the proverbial grandma who just wants an app, or just say like someone who just wants a simple app on their phone, and they're not ready to sort of go to the level of running their own server at home and things like this. And let's imagine they're using some kind of Floresta technology built into, their on-chain Bitcoin app on their phone. When they go offline and come back online, can you just talk to us about this? Because in this context, like if you're talking about like a server that has to resync up to the chain tip, that's one thing. But how does it work in Floresta in an assume Utreexo context? Is it just kind of re-downloading the latest? Like, can you just explain a bit about that?
Yeah, for some Utreexo, if you go offline and come back, you need to re-download everything. For proof of fraud proof, you can just redo proof of fraud proofs. So if you, let's say you have 3 months worth of blocks that you have to catch up. It's a lot of blocks. Probably you don't want to do this on your phone, so you can redo the proof of fraud proof routine and just skip to the latest blocks. And my assume Utreexo, no, it's a problem with assume Utreexo is that if your binary gets old, you actually have to catch up a lot of blocks. So it's actually another challenge that you have there. Floresta, the last release is very old, so right now I have to catch up a few thousand blocks. So it takes a little time now.
Even to run the proof of work fraud proof thing?
No, running the assume Utreexo. Proof of fraud proof will always get you to a very recent block.
Gotcha. Okay. And so I'm curious, do you think that would be a competitive UX, like given mobile apps and what the user expectation is nowadays? Like, do you think it would be comparable to just kind of open the app and it's already it's loaded my balance, this kind of thing?
There will be degradation. I don't see how you can compete with server. Hopefully it's not too much to be perceptible, but I feel like there would be some degradation. There's no way you can make it compete with a server.
Yeah, gotcha. Okay, so I guess summing up then, this project, this idea could help a lot more users be validating clients, as opposed to right now where there's a lot more trust being placed in the various servers. So can you just, I guess, sum things up and any closing thoughts there?
As I say, I really think there is space for something in between, like some experimentation. Something may work out, something may not. This is why I don't make wild claims about it, but I think if you can manage to make something in between, there is a lot of use case there. There's a lot of people that can benefit from this. If you have most of the economy using Bitcoin, like a third-party server, trusting kind of thing, it's going to be bad. We're seeing in altcoins things like a whole country being shut down from the infrastructure of a major service provider. This is not the kind of thing we want in Bitcoin. So I think there is space for some experimentations there. And I think there is people that's going to benefit from this. So if you're anyone has any thoughts, especially on the UX side, because there's a lot of challenge there, we are always open to feedbacks and thoughts from different people, even if you think that's impossible, that's not worth. It's always good to hear new opinions. So there's the GitHub and we have a Discord as well. So I'm always looking for feedback. So far, the reception of the product is being very good, very positive. And this is why I'm sometimes a bit scared because it's too positive. I have to be missing something. So yeah, feedbacks are always welcome.
Yeah, well, I certainly think it's an interesting project, and it might be interesting if more people were to look at it. I will put the links in the show notes, but just reading it out, as I see, it's github.com/vintium.org/Floresta to find the GitHub, and I will link to obviously your X and your blog and some of the other links also in the show notes. And listeners, if you found this interesting, make sure to share it. Davidson, thank you for joining me today.
Thanks for having me.